And then the intersection of the faces are edges. So in this first polyhedron here, I'm going to draw a couple of edges blue. So those are examples of edges. And then the edges meet at vertices. So the vertices are in orange there, so there's a bunch of them, but there's a few of them, for example. Okay, so just some basic vocab you'll need to know. So which one of those shapes is not a polyhedron? Okay, why not? It doesn't have edges or vertices. What part of the definition is violated? A polyhedron is a three-dimensional figure whose surfaces are polygons. Yeah, so what's not a polygon? Circles are not polygons. So the third one is not a polyhedron because it's got circles, and circles are not polygons. So polyhedrons won't have any kind of curves in them. Okay, so let's just do a little bit of like just counting up the faces and listing the faces and vertices and edges. So first of all, faces. Isaac, how many faces does that example figure there have? How many?
4.
Tell me which ones you see.
What do you mean? Which ones I see?
What shapes are you seeing?
Oh, like a square, triangle, rectangle, and parallelogram.
How many triangles do you see?
2.
Okay, so we've got 2 triangles, and then the rectangle here, that's 3, and then the bottom, that's 4, and then the one over there is 5. Okay, so let's name them. There's 5 faces. Oh my gosh, seriously? You're making so much noise, nice. Lauren, list the faces for me. So like RUV is one of them. Name the rest of them. STW. Careful. RSTU would work, or RUTS would work. Yeah. RSTU. Jalen, what are you doing?
I don't know.
I don't either. Stop. Thank you.
SWVR.
SWVR.
And TWVU.
TWVU. Yeah, so make sure that you put them in order, the vertices in order. So like when she originally had said RSUT, the order was not correct because you have to connect them in the order that it's written in. So just be careful when you're naming those. And there were 5, so make sure you got all 5 of them. Okay, vertices. Drake, how many vertices are there? 6. So 3 in the front, 3 in the back, and that's all of them. So list them. What are they? Name them.
R. S. U. T. V. W.
R, S, T, U, V, and W. There's no specific order for those. Just make sure you have them all listed. Okay, edges. Andrew, name edges.
V.
I'm going to trace it and write them down here. Go ahead.
VR.
VR.
RU.
RU. Oh, wait, you said UR, didn't you? Okay, UR. Or did you say RU?
doesn't matter.
Oh, okay.
RS,
RS,
RT,
RT,
UTM,
UT, I mean.
and then ST.
Does this thing work? Is that good?
Mm-hmm. It doesn't usually work as well as that one, but it's fine. I mean, it'll charge. I never think about it because I never really use it. Okay, ST. Okay, what else?
TW, SW, VW.
And VW. I strongly recommend you trace over them as you're writing them down because it's really easy to confuse which ones you've already written and to miss some of them. Okay, so there's how many total? We'll count again. 9. Okay. That's kind of like stuff that's actually in Chapter 11. Now, there's something we have to go back to from Chapter 10 that involves finding areas. And first of all, regular polygons. Do you remember what it means for a polygon to be regular? That was a vocab word back from Chapter 6, maybe? Equiangular is part of it. Okay, to be regular, it has to be equiangular. What was the second part? Yes, good. Regular is how you describe a polygon that's both equiangular and equilateral. So that vocab word is regular. Again, that's not something new, but we haven't used it much lately, so you might have forgotten what that meant. Okay, so there's 3 different kinds of regular polygons that we're going to talk about in the rest of this lesson. The first one is a regular triangle. Okay, if a triangle is regular, it's going to be equilateral and equiangular. What will its measures be? 60. Not the best equilateral triangle I've ever drawn, but it'll have to do. Okay, so it's equilateral and equiangular, so all of those angle measures would be 60 degrees. Okay, so there's a regular triangle. Every regular triangle is going to be an equilateral triangle that's also equiangular. So 3 congruent sides and angle measures that are all 60. Oops. Okay, and we'll talk about this when we start doing the area, but you can cut regular triangles into 30, 60, 90s. So we'll be using what we know about 30, 60, 90s to help us find the area of regular triangles. Now, a regular quadrilateral. Okay, so here's a regular quadrilateral. If it's equilateral and equiangular, what kind of shape is it? A square. Every regular quadrilateral is a square. My square is not very good. You'll have to do. Okay, so if it is a regular quadrilateral, it must be a square. All those angle measures are what? 90. It's a square. So every regular quadrilateral will have 4 congruent sides. Its angle measures are all 90. So it's a square. Okay, so those are pretty, basic, simple. The last kind of regular polygon that we're going to talk about in detail is a hexagon. But in general, I want you to remember, we kind of talked about regular polygons before when we were doing, remember the n minus 2 times 180 thing, where you would find the measure of the angles divided by n, the sum of the interior angles divided by how many there are, that kind of stuff, was very beginning of this chapter, this semester. Sorry about that, but that will be on your final. Okay, so in general, a regular polygon with n sides, actually I'm going to use a different color. A regular polygon with n sides You can divide any regular polygon with n sides into n congruent shapes. Every regular polygon. So what is this shape here? What is that polygon? That's a pentagon, right? Okay, so a pentagon can be split into 5 congruent parts. What will these shapes be? Triangles. Every regular polygon can be split into triangles that are all congruent. So if it's a pentagon, there'd be 5 triangles. If it's an octagon, there'd be how many triangles? 8. If it's a hexagon, there'd be 6 triangles. So n, is going to be the same number of sides as it is congruent triangles. So to do the area, if I wanted to find the area of this pentagon, for example, I could find the area of one of those triangles and then multiply it by what? 5. Okay, so you could do the area of the triangle multiplied by 5 would give you the area of the pentagon. So that's kind of how we're going to deal with finding areas on these regular polygons. Just kind of think of it as a bunch of triangles. Okay, what is the shape on the right here? Octagon. How many sides? Okay. The nice thing about the octagon is because it's an even number of vertices, it's a little easier to draw the triangle. So if you just connect opposite vertices, you don't have to eyeball it quite as much as the pentagon. You can find the center very easily. So again, if we found the area of one of those triangles, the octagon area would be one of those triangles multiplied by what? 8. There's 8 congruent triangles. Okay, so it's important you realize that because it's regular, that's why you're getting congruent triangles. It's not just, 8 random triangles. They're all congruent to each other. So finding areas of those kind of shapes, we'll just find the area of one triangle and multiply by how many there are. Okay, so regular hexagons are special. They're similar to the pentagons and the octagons, but they're special because when you draw in a regular hexagon, when you draw in these triangles, oh, my picture is not very good because my segment was not quite long enough. It should have, here, you know what? I'm just going to stretch this out a little bit. I didn't quite make it to the center when I was drawing on my computer. Okay, so regular hexagons, how many triangles can you divide that into? 6. Just leave it on my desk. Thanks. Oh, sorry. What kind of triangles will they be? That's what I'm trying to say. If you wanted to know this angle measure right here, I could take 360 and divide it by what? 6. What is that? 60. In a hexagon, and only in a hexagon, that angle measure right there would be 60. And then why are these congruent? Oh, you maybe don't know that. If you put a circle around this polygon, what would those things be of the circle? They're radii, so they're actually congruent. Every regular polygon can be inscribed in a circle. So those are actually congruent, which means these are the same. And what are they going to be? 60. In a hexagon, and only in a hexagon, you're going to have equilateral triangles. Okay, now that won't happen, like let's say the pentagon here. If you try to do the same thing on that previous page, if you try to find, it's called a central angle, right? The one where the vertex of the center of the circle. If you try to find the central angle by doing 360 divided by 5, that's 72. Okay, this angle in here would be 72 degrees. So that's not an equilateral triangle. That's something that's special for pentagons. It'd be the same thing with the octagon. If you divide 360 by 8, you get 45. So in a hexagon that's regular, it's super special because it will give you 6 congruent equilateral triangles or regular triangles. Okay, and so there would be 6 of those triangles. There would be 6 of these triangles. But remember when, and we had done a few of these recently, when you wanted to find the area of one of those equilateral triangles, you would draw in an altitude here, creating what kind of triangles? 30, 60, 90. So that was 60, right? So when you cut that in half, you now have a 30, 60, 90. So how many of those triangles would there be? There's 6, the purple triangles. How many red triangles would there be? There'd be 12, right? So if you wanted to look at the congruent 30, 60, 90s, there would be 12 of those. I guess I was supposed to draw, I didn't really think about it. I was supposed to draw this over here. What is happening, Jalen? Mario's asleep, so.
His iPad is he's not asleep.
Go up and then
Okay, what are you going to do about your iPad being dead?
she was doing this.
Huh?
She was doing this. Virtual.
Yeah, Jalen's using it. I don't know how both of you are sitting here with the.
So,
Copy that little right triangle onto the other one. So there's 6 equilateral triangles. There's 12 of the red triangles. There'd be 6 of the purple ones. Okay, so this is what we're going to be kind of basing everything on. When you have a 30, 60, 90, when you have a regular triangle, it's always going to be a 60, 60, 60. And you can always cut it into 30, 60, 90. When you have a regular quadrilateral, it's always a square. And when you have a regular hexagon, you can always split it up into 6 equilateral triangles or 12 30, 60, 90s. So these are asking for perimeter and area. Which one's easy?
Neither.
Oh, come on. Which one's easy? Perimeter. Perimeter will just be 8 times 3. I'm actually going to do that up here. Okay, so the perimeter is going to be 24. That's the easy part. Now, when you go to, I told you these are all regular. Okay, you can assume that these are regular. And that means that this is 60 in every corner. Okay, every time you have an equilateral triangle, you can draw in an altitude and cut it into 2 what kind of triangles?
right.
Yeah, what else? 30, 60, 90. So if we drop an altitude, that'll cut that one in half and make it a 30, 60, 90. I'm actually going to change the color to that. All right, so this is the hypotenuse. All right, what will the short leg be?
4.
4. And then the long leg will be
4. Radical 3.
4 radical 3. Now, when we go to do that, what's the area formula for a triangle?
Base 1/2 times base times height.
1/2 times base times height. Okay, what are you going to use for your base? 8. Okay, that's 4, but the whole base is 8. So 1/2, what's the height?
4 radical 3.
4 root 3. So the base is 8, the height is 4 root 3. Okay, what will that be? 16 root 3. What's the label?
Unit squared.
Unit squared. Okay, so every regular triangle, you can always drop an altitude and cut it into 30, 60, 90s. That always works. Okay, the next one's a hexagon. Hexagons, we can split into stay out of her desk. I mean, I already said that to you once. Okay, so this is a hexagon. Again, it's regular. So we're going to go ahead and draw in a triangle right here. Actually, you know what? Let's do this. Let's draw in the regular triangle here. So this would be your 60, 60, 60. I feel like that's kind of thick. And then how are you going to find the area of that equilateral triangle?
Break it up into 60 times.
Break it up. Yeah, we're going to do the area of that multiplied by 6, right? We're going to break it up just like we did this one. So we're going to cut that, drop an altitude there. Kind of missed. Drop an altitude, and that will be a 30, 60, 90. What length do you know?
The radius.
Yeah, actually, you do know the radius. What is the radius? 10. Because this is an equilateral triangle, that 10 there is also the radius, that length there. How long is the short leg? 5, which means that this hypotenuse has to be 10. Okay, in case you didn't think about it being a 60, 60, 60 triangle. Even if it's a 30, 60, 90, it's still going to be the same thing. And then what is the altitude going to be? 5 root 3. Okay, so you just have to make sure you know what you're finding. You can either find the area of this whole entire triangle and multiply by what? 6. Or you can find the area of this little 30, 60, 90 and multiply by 12. But you just have to make sure you pay attention to what you're finding. I think it's probably easier to just do the area of this triangle multiplied by 6. But just remember that when you do that, you're going to have to be using the right length for your base. Okay, so let's do perimeter real quick because that's actually really easy. Parker, what's the perimeter? 60. 10 on a side, 6 sides, 60 units. Okay, and then for our area, the area of one triangle is a half base height. Jonathan, what should we use for the base?
The triangle.
The blue one.
Yeah.
What number should we use for the base? 10? And what's the height?
5 root 3.
Okay. When you multiply those together, what do you get?
45 root 3.
So half of 50 or else half of 10 is 5 times 5. 25 root 3. Unit squared. Is that our answer?
So,
No. What do you have to do?
4 plus by 6.
Multiply by 6. Okay. There's 6 of those triangles. So if you find the blue triangle, you multiply that answer by 6. If you found the smaller 30, 60, 90, then you multiply by 12. If you were doing the pink triangle that I just colored, instead of doing 1/2 of 10 times 5 root 3, you would be doing what? If you wanted to find this area, it wouldn't be 1/2 of 10 times 5 root 3, it'd be half of 5 times 5 root 3. So it would give you the same answer in the end, because you'd be multiplying by 12 instead of by 6, but just make sure you know which triangle you're finding the area of, if it's the right triangle or the big triangle. Okay, so 25 root 3 multiplied by 6 is 150 root 3. That's good. Okay, so squares are actually really easy compared to the triangles and the hexagons. The hexagons obviously are more complicated than the triangles, but you just have to remember that for the triangle, you always just drop an altitude. Okay, for this square, have any ideas about how to find that area, perimeter, whatever? There are a few different ways to think of it. I could draw a triangle like this. I could draw a triangle like this. I could draw a triangle like this. There are lots of different ways to draw that in.
Square.
It's a square, yeah.
Right, it's just simply that.
Because I told you that these are regular,
Okay.
you'll know it's a square because regular is either a regular triangle, a square, or a regular other kind of polygon. Yeah, so this is definitely a square. We know that for sure because it's a regular quadrilateral. If let's say I draw in, this is usually the triangle that I would do. So just like back here where we're basically drawing in a central angle, you know how like if you cut that up, there'd be 6 of those, right? So if we do the same thing over here, how many of those triangles would there be? How many of those triangles would there be? There'd be 4, right? What is this angle right here? 90. So you would know that for sure because you can do 360 divided by 4 would make that central angle measure 90 degrees. So we know that's a right angle. Max, what is the side length? It's also 10. What kind of triangle is this? Oops. Yeah, it's a 45, 45, 90. So this would also be 10. How long will this side be? 10 root 2. Good. So every square, that's always going to happen. It's always going to form 45, 45, 90 triangles. Okay, so if we find the area of this triangle, Monica, what would we multiply that by to get the area of the square? How many of those triangles would fit inside that square? 4. So you can find the area that triangle multiplied by 4. It might be a little easier. It just depends on the problem. We can still use the side squared formula if you want, right? So it doesn't really matter whichever way you think is easier. Let's do perimeter first. Perimeter is almost always easier. 10 root 2 multiplied by 4 is 40 root 2. Okay, so our perimeter is 40 root 2. Now, you can approach this the same way that we just did with the hexagon. You can find the area of that triangle, then multiply, or you can just do side squared. So I'm going to kind of do it both ways just so you see that you have options there. So if you wanted to do the area of the triangle, what are the base and the height?
2, 5 root 2. I know 10 root 2.
Okay, so you're thinking like this base and this height, right? You don't have to do that because that's a right angle, right? 10 and 10. On a square, because it's always perpendicular, you can always use those two segments to be the base and the height. So that's actually a really simple way to find the area of that triangle. So it's just 50. But that's not our answer. We have to do what? Multiply by 4. So again, you'd have 4 congruent triangles if you drew in those segments there. Bye, Lauren. We'll miss you. Have a good weekend. She's leaving. She's tired of us.
I leave too.
Okay, so that's one option. Your second option is, hey, be nice. Your second option would just be to be doing side squared. How long is this side? Yeah, it's a square, right? So it's 10 root 2. So it just kind of depends on whether you mind that having a radical there or not. It's kind of easy to just do, it's a square, so it's just side squared. So it's 10 root 2 times 10 root 2. I'm out of room. Let's scoot this over a little bit. Will, when you multiply those together, what do you get?
100 square root 2.
100 times what?
Times 2.
Times 2, yeah.
It will come out to 200.
200. See? Got the same answer. So, this, it really doesn't necessarily mean one's easier than another. It could just depend on the numbers. So, like I said, I really think this is easier. It's just whether you're going to be able to do that correctly and not make a mistake in the multiplying. Okay, but squares you can always break up into 45, 45, 90s. Now, just another comment about squares. Let's draw another square here. If you drew in, because depending on what they give you, it might be easier to do a different triangle. If you drew in that diagonal right there, what are those two triangles going to be? They're also 45, 45, 90s. Oops, didn't mean to do that. Okay, so if you wanted to draw in one diagonal, you would create 45, 45, 90 triangles. We drew in that little triangle right there. You could also draw in my square is not the best, but I don't have to do. You can also draw in this little triangle here. Let's get here. You can also draw in this little triangle. What would that angle measure there be, and what would that angle measure there be? They're also 45, 45, 90s, okay? There's a ton of different ways to cut squares into 45, 45, 90s. So if you're having trouble with the one triangle that you drew, try a different way. Okay, so you get a 45, 45, 90 triangle here. You get a 45, 45, 90 triangle here. And you get the 45, 45, 90 triangle that I have down there in purple. So all of these, pay attention to. Squares always give you 45, 45, 90s. There's a bunch of different ways that you can split it up into triangles. But the triangles are nice because they're always going to be 45, 45, 90s. So look at that square down here. Does anybody need me to leave that there for a minute? Are you done with that? Okay. With that picture? You done with that? Okay. Isaac.
Yeah.
Do you know how long this segment would be?
It would be 4 root 6.
This part's 4 root 6?
Or the whole, or it would be 2 root 6.
Okay.
But like, all the diameter.
Yeah, the whole entire side here would be 4 root 6, right?
Yeah.
So on that one, I probably wouldn't even draw in right triangles. I would probably just notice that that's actually half of the side length. The square's only one that works like that. So what would this side length be? Yeah, it's a square, right? So it's also going to be 4 root 6? Oops. No? Or not? So remember up here where I said it said that they were regular? Regular means it's equilateral. So every one of these shapes, it's the quadrilaterals on these are always squares. Yeah, so it's going to be a 4 root 6 and a 4 root 6. So for perimeter, Haley, tell me how to find the perimeter.
4 root 6 times 4 times 4.
Times 4? What is that?
16 and 6.
Good. Okay, and then let's do the area. I'm going to move this. I don't even know. I guess I'll move it here. Area. What color was I using? I was using purple. Jonathan. Hollis.
Yeah.
Take that red lid container over there. Turn around and look at me. I keep forgetting to give you your container. Jalen's going to give it to you.
Okay. This t-shirt?
Just have...
Ignore them.
I keep forgetting to give that back to you since you're here and I thought of it.
I was going to ask you, do we want to do breakfast next Thursday for people?
No.
Because Lauren said you were in charge.
Okay.
Because I said we could do, it's a day 5, it's a late arrival for PLC. We could bring in stuff next Thursday for these people.
I thought
Monday's a late arrival, Thursday's a late arrival. Because it's a day 2, day 5.
I don't know. How about we talk about it when I'm not teaching? Oh, shoot, it's 2:10. Bye. Area is 4 root 6 times 4 root 6. Janae, how do you multiply that?
16 root 6. Oh, wait, no. 96.
Times 6. Okay, so 96 units squared. Okay, so all of the shapes, you're going to have a hexagon in the homework. Remember that you want to start by drawing in an equilateral triangle and dropping in altitude and using a 30, 60, 90. Okay? So use your examples. The homework is going to have mostly this stuff with a little bit of the first stuff we did. Okay, and then next week we'll be doing volume and surface area of 3D shapes. Have a good weekend.